Okay. Before I start final exam preparation, I kindly ask you to do the student evaluations. I know that usually when I receive emails about evaluation, I tend to ignore them if it's not totally vital to me. But for you, I feel like this is a really great opportunity to improve the course quality. If you saw something that you didn't like, you can write. If you saw things that you liked, also it helps you in the sense of, when you take other courses, if, for instance, you like extra credits, and if my department chair sees that most of you like that, and then it helps you to learn, or help you learn, maybe other professors will start doing that too. So it's just good to do the student evaluations for the reason that I said it's most beneficial to you than me. I mean, it's really beneficial to me in the sense that I can improve my teaching, but overall, you are the one who are being educated and learning, and your opinion matters the most. So that's why I encourage you to do the student evaluation. And as I mentioned, anything that you think that can be improved, mention. Anything that you think, was good and you liked, also mention for the reasons that I just stated. And when you do the student evaluation, make sure that you read the question well, because I have colleagues that they receive nice comments, but the evaluation is bad because the students just didn't read the question well. So if they say that instructor cared about you, A, strongly disagree, and then D is a strongly agree. So just make sure to read the question well, so your opinion would be reflected in student evaluations. The other thing I want to mention is your last quiz, quiz 5. I realized lots of you missed it, although I tried my best to communicate this is the deadline. And I told you the deadline was Friday. I told you, do you prefer if I extend it? And most of you said yes. But now lots of you missed the quiz 5 deadline, and I had emails from lots of you that can I take it, and always tell if I make an exception for one student, I should make it for all of you to be fair towards all of you. And this week is no exam week, so I don't want to schedule exam this week because it's just contradictory with university policies. I don't want to be in trouble. But if you miss the deadline and you really want to take it, or if you had a poor performance and you want to retake it, just ask your academic advisor, email me, and as long as I have some documentation, and some of you had reasons why you couldn't take it on Sunday and all that, I'll try to work with you. So just email me, and I work one-on-one basis to the best of my ability. But as I said, I cannot just have quiz 5 this week because you're not supposed to have an exam this week. Are we clear on quiz 5? Any questions? Okay, so if no question about quiz 5, I graded your exam as you saw just the night that you had the exam. I went through the exam and graded that. So you did much better than the students last semester, which I'm happy. Still, the average is not as high as what I wanted, but still, I think you're doing decent. And at this point, I'm just not going to bore you with talking about you should study and all that. We have 1 week. I try my best to prepare you for the final. As I said, I just want all of you to get good grades, and I don't want anyone to fail. For that, I'm going to, each lecture this week, I'm going to have review sessions. And any questions? I'm going to have review session, and I'm going to have extra credits at the end of each session to make sure that you learn and succeed. But you should also study these materials after each class. And I also wrote the, how many students got A's or B's and all that. And lots of students had A's and B's. And most of the students that have F's are students that they don't show up to the class. And I said from the beginning of the semester that if you have more than 6 unexcused absences, you're automatically failing the class. And that's the case here. But for students who care, come to the class, I provide makeups, I provide makeup for everyone, but I have like extra credit opportunities. I try my best to help you succeed. But if you don't come to the class, I cannot study for you. I try my best to help you learn. Okay, I also included your exam here, the solutions, but I feel like some of you have fundamental issues with the previous chapters, so me going through this wouldn't be beneficial to some of you. So for that matter, I have this here. First, I start reviewing from chapter 4. As I mentioned, your final would be chapters 4 to 10, anything that I talked about in the class, okay? So if you see a question in the previous semester that which of the following ionic compounds are insoluble in water, I didn't talk about that, so you don't have to worry about it. But anything that I talked about in the class, chapters 4 to 10 would be in your final exam. And I'm going to start reviewing today. So I make sure that you have the grasp of the materials. And you should be having, as I told you, to circle your answers on your exam. So now that I posted, you can compare. But if you still need your Scantron, you feel free to stop by my office to take it. Any questions so far? Good. Okay. So now, can anyone tell me what was the first atomic theory that we studied in our class? Or what is atomic theory? What do I mean when I say atomic theory? Anyone? I mean, so what is, even with this slide, no one can tell me that? Yes?
Basically just be a theory about how atoms work.
Yes, kind of. So we have like electrons, protons, neutrons in an atom. And we want to see how they are arranged in an atom. And as we started chapter 4, and I told you there were scientists, Leucippus and Democritus, that they believed atoms are indestructible. So if you want to talk, I just asked you to go out of the class. As you saw, I stopped attendance because from now on, it doesn't matter, I mean, it matters that you be in the class, but I just don't keep track of it because students who are failing, they are failing automatically. So if, you don't have to, have an excuse reasons to not to be in this class right now. So just leave the class. I have so many materials to go through. I want to review 10 chapters in 3 sessions. And I cannot do that with distraction. So Leucippus and Democritus, as I mentioned here, they believed that atoms are indestructible, meaning that if you have an atom, we cannot break it to simpler constituents, meaning that they don't have subatomic particles, they don't have anything else that later on scientists call electrons, protons, neutrons. And we said this theory wasn't widely accepted after John Dalton said so, for whatever reason. So when John Dalton said, they had the atomic theory of John Dalton that stated each element is all composed of tiny indestructible particles called atoms. As we said, the same thing that the other 2 chemists said. And all atoms of a given element have the same mass and other properties that distinguish them from atoms of other elements. And as we learned, this is not entirely correct. Can anyone tell me why? Isotopes, right? So this is not entirely correct, and the previous one wasn't correct at all. And atoms combine in simple whole number ratios to form compounds. And that is correct. For instance, you have CO2, you have CO, right? we have whole number ratios when atoms combine with each other to have molecules. And then we talked about plum pudding model. Do you remember which scientist came up with this model? Thomson, exactly. So he said we have other particles in an atom. So atoms are not indestructible. We have protons and electrons. And he said that if we consider, atom as this dessert, basically plum pudding, or you can also think of it as blueberry muffin, right? That these blueberries are your electrons, and these, your cake, or your muffin would be your positively charged sphere. And later on, we realized this model is not correct either. Do you remember who corrected this model? Rutherford, right? So he wanted to prove what his professor was saying, or advisor was saying was true, but he proved wrong. And he came up with this theory, the nuclear atom. So if I ask you which scientist came up with nuclear atom, Rutherford is the answer. And it says most of the atom's mass and all of its positive charge are contained in a small core called the nucleus. And I gave that in the exam, and here I put, negative, and that made the sentence wrong. So make sure to study everything really well. Most of the volume of the atom is empty space through which the tiny negatively charged electrons are dispersed, and there are as many negatively charged electrons outside the nucleus as there are positively charged particles, protons. So the atom is electrically neutral. So if you just have one magnesium atom, you don't have any charge. Okay? Do you remember what did we call the charged particles? Ions, exactly. And we had cations and anions. And cations had positive charge, and anions had negative charge. What elements usually have or form positive charge? Metals, right? And which ones have negative charge or form negative charge? Non-metals. Okay? Questions? And here is also a demonstration of Rutherford model. So basically what I just, or your book rather, wrote in the previous slide, I have here, or your book has here in demonstration and a picture. Okay, so positive charge and negative charge, do they attract each other or repel each other? Positive, negative, right? They attract each other. So electrons and protons, they attract each other. But what about negative, negative? Or positive, positive? They repel each other, right? So if you have two protons, they repel each other. But if you have one electron and one proton, they attract each other. Question? Okay. And subatomic particles, remember, protons, neutrons, electrons. What is the charge of one electron? -1 or 1-, right? What about proton? +1. What about neutron? Neutron is neutral, right? And then, do you remember atomic mass unit? Can anyone tell me what was atomic mass unit? So these numbers, if you report the mass of one electron, one proton, one neutron, these numbers are really big to write and it's difficult to work with, right? And the order is really low, 10 to the power of -27. Can't even imagine how small that number is. So that's why scientists came up with atomic mass units. So instead of writing this big number, they just write 1.0073. Or like for electron, they write 0.00055. So what I need you to know is that to know approximately the mass of proton and neutrons are the same and is 1 atomic mass unit, and mass of 1 electron is, near 0, almost 0 atomic mass unit. That's why when we want to report atomic mass of one fluorine atom, we just count the number of protons and neutrons. We don't count the number of electrons because that number is basically 0. Any questions? Good? Okay. Now, periodic table of elements. Do you remember that scientists put elements in a table and we call that periodic table, right? Who was the first person who put elements in this periodic table? Mendeleev, exactly. And how did he arrange them? Based on atomic mass, exactly, or mass of the elements. But what is the periodic table that we're seeing on the wall? How did scientists after Mendeleev arrange that? What's that?
Like, according to where the valence electrons are?
So, yes, so when they arranged it based on some other factor, it was basically based on the properties of elements also periodically repeated. But how did we put them there? You see that hydrogen is 1, helium is 2, lithium is 3, beryllium is 4, and all, you see that 5, 6, 7, 8, 9. It has an order. How did we put them there, or scientists? Atomic number. Okay, so remember, the modern periodic table is based on increasing number of protons, which is atomic number, but the periodic table that Mendeleev had was based on atomic mass. And here, you see atomic number, right? And then you have the chemical symbol or atomic symbol, and then below that you have atomic mass. And you should be able to read the table for your exam, both atomic number, atomic mass, to use that in several of your questions. Question? Good? Great. Okay, so here is just what I just told you. And if I ask you what is periodic law, you say when the elements are arranged in order of increasing relative mass, certain sets of properties recur periodically. Even if I say here atomic number, that sentence is also correct, So periodic law stands both for how Mendeleev put elements together and for the modern periodic table. As you see, when we have the elements, as your friend mentioned, when you put that in the order of increasing atomic number, you see certain properties, repeat, like lithium, sodium, potassium, rubidium, cesium, francium. All of them are really reactive metals. Or fluorine, chlorine, bromine, iodine, astatine. All of them are reactive nonmetals. Or helium, neon, argon, krypton, xenon, radon. All of them are noble gases which they don't want to participate in any reaction. So, are we good with periodic law? Good? Questions? Okay. So this is one of the most important things that you should know for this class. Metals, nonmetals, metalloids. Specifically metals and nonmetals. And knowing their location in periodic table, and I'm going to zoom this picture a little so you all can see well. So if I tell you which one of these elements have, and this is something that we talked about in chapter 10, but it's also worth mentioning here. Do you remember metallic character? So what is metallic character?
It increases as you go down the time.
Yeah, so when you go up to down, metallic character increases. And metallic character is really connected to ionization energy that we talked about, right? So metals have certain properties. One of their most pronounced property is their ability to lose electrons. So if you have an element that more readily loses electrons, we call that, having more metallic character. So in your periodic table, and I always tell you to look at here, the groups that you have, metalloids. So here, if I go up to down, here, you have nonmetals, right? Okay. And then here, you have metalloids, and then here, what do you have? Metals. So if I say in periodic table, when I go up to down, metallic character increases. True or false? True. Can everyone see that? Or if I go left to right, right? So here you had metals, right, throughout here. And then you had metalloids and you had nonmetals. So left to right, do you think metallic character increases or decreases? Decreases. So if you learn that, ionization energy is reverse. Okay? And I'm going to talk about ionization energy later. But what I need you all to know is which ones are metals, which ones are non-metals. When you look at the periodic table, and the periodic table that they give you in the exam is black and white, it doesn't distinguish which one is metal, which one is non-metal, so you should be able to distinguish. And when I was teaching these, each session I asked you to remember 3 elements and all that. At this point, it's just too late to remember if you haven't already. But remember, lithium, sodium, potassium, rubidium, cesium, francium. If you look at the periodic table, you should know that these are all metals. Okay? And then here, aluminum, probably you know it's a metal, right? Aluminum foils. Aluminum is a metal. And then here, tin. Maybe you know, heard of tin too. That is a metal, maybe not. If you didn't, just remember. And then bismuth. And here, we don't deal with these ones here much. So as long as you know aluminum, and also gallium, I guess, remember that it's a metal. And then tin, bismuth. And then if you remember that, anything below them are also metals. Okay? Does that make sense? And here, you have carbon, phosphorus, selenium, iodine, radon. So also anything above them would be nonmetals. And the rest in the zigzag are metalloids. This is the best I can help you to remember this. So just make sure to practice this at home and then make sure you know. And some of you email me that you're not understanding the materials well. When I'm teaching, if you're not paying attention, so probably you're not learning well either. So make sure when I'm talking about these things, you pay attention, so hopefully you can get the idea of what I'm talking about. Any questions about metals and nonmetals? As I said, when I talk about ionic compounds, molecular compounds, when you want to write their formulas, if you don't know what is metal and non-metal or how to distinguish them, you cannot do anything. So make sure to know this well. Okay. Now, do you remember what was main group, or what were main group elements and transition elements?
Main groups are group A and transition elements are group B.
Exactly. So the ones that we denote with A's, 1A, 2A, 3A, 4A, 5A, the ones that we write with A's are main group elements. But the periodic table that you see in the exam, most probably it would be like 1, 2, 13, 14, 15, 16, 17, 18. Remember, like your wall, you see? There are 2 ways to name the groups in the periodic table. One way is like A's and B's, the other is just like overall, naming them 1, 2, 18. So even if you have 13 here, remember that was just, you can deduct 10, right? It would be like 3A, 4A, and all that. So these are your main group elements, the ones that have A's, and then these are your transition elements. Okay. Can anyone tell me which of these elements had one type of charge? There were some of your metals and some of your non-metals, right? for the sake of our course, I told you the elements that are in group 1A, except hydrogen, which is not a metal, all the metals in group 1A, they have only one type of charge. So I write lithium plus, and here is like group 1A. So the number of valence electrons in lithium is 1, and it loses that electron and forms a charge of plus 1. Does that make sense with the things that we learned in chapter 10? And then it's the same as sodium, potassium, rubidium, cesium, francium. So group 1A metals form charge of plus 1 or 1 plus. What about group 2A? Elements in group 2A. What is their charge? Exactly, because they have 2 valence electrons, they lose those 2 electrons to form ionic bonds. So I write Be2 plus, Mg2 plus, Ca2 plus, Sr2 plus, Ba2 plus, radon 2 plus. And remember, try to zoom this a little bit more. Okay. In your exam, when I give you Ba, in one of the answers I put Br. In the other I put boron, B. So make sure to read the atomic symbols well, right? I give you the periodic table, so it's just like you feel so bad if you knew the answer but just didn't pay attention, okay? Can anyone tell me another metal that had only one type of charge, that I can just write it here? Aluminum, exactly. I just put here 3 plus, and it's in group 3A, so it has 3 valence electrons, so when it forms ionic bonds, it just loses that 3 electrons. What else? Zinc, exactly, 2 plus, and then it's in group 2B, or you can just remember number 2. And then, what else? Silver, exactly, and this is 1 plus or just 1. So you can learn this in the way that you have like a zigzag here. Okay, so you should know that for the sake of your exam, because I ask you questions that involve writing ionic compounds that if you don't know this, you cannot write them. Any questions so far? Can anyone tell me one nonmetal with its charge? If it wants to form an ionic bond, what would the charge be? What's that? Sorry, what? I'm just not hearing. Not that you know. So here, for instance, fluorine, right? I can write the charge of -1. And the reason now that we learned chapter 10, fluorine has 7 valence electrons, and it wants to reach electron configuration of the noble gas after that. So it wants to reach an octet. So it has 7 electrons. It gains 1 more to reach an octet. So it would be F minus. Can anyone tell me what is the name of F minus? Fluoride. Remember, for non-metals, for metals, we just write the name. We just say lithium, sodium, potassium, right? Ion. But for non-metals, we use base name of the non-metal plus IDE, fluoride, right? And then here, Cl minus, Br minus, I minus. So we call that fluoride, chloride, bromide, iodide. Or oxygen. It has 6 valence electrons. It wants to gain 2 more. So we write O2 minus. In order to reach an octet, it should gain 2 electrons, or S2 minus. And we call the first one oxide, the second one sulfide. Okay? What about nitrogen? It's in group 5A. It should gain 3 more to reach an octet, right? So it would be N3 minus. We call that nitride. Again, base name of non-metal plus IDE. So these ones you should know of the memory. And you can just write these based on the octet rule that I just taught you in chapter 10. So probably now it would be easier to write these compounds because now you know why you should memorize these numbers. So one type of question that you're going to see, now we're getting more real questions that you see in the exam. I say, what is the ionic compound that forms between K, or like potassium, and nitrogen? I just give you like 2 minutes to look at this, so I kind of like prepare your extra credit quiz real quick too. Okay. So how you do that? What is the charge of potassium? 1, right? Plus. And remember that is plus. And then what about nitrogen? What would be the charge? Exactly. And to write this, so you have 2 ways. One way is that I told you ionic compounds, previously I told you that they are neutral as a whole. They have charged particles, but in general, they don't have any charge. So you have 3 negative charge, and you have 1 positive charge. How can you have 3 positive charge? If you have 3 of potassium, right? Because 3 multiplied by plus 1 would be plus 3. So it would be K3N. Or you can say simply, you switch these charges, you put them here. So it would be K3N, whichever is more comfortable for you. Now naming. If I ask you to name this, you say potassium, what else? Nitride, remember? And you have the table of polyatomic ions, which you don't have to worry about, I'll give you in the exam, but you have nitrite, nitrate, and all that. Just remember, when you have IDE at the end, nitride, it means that you have just 1 nitrogen atom. It's not like nitrite or nitrate, it's not like NO3 minus, or you don't have polyatomic ion, that's what I mean. Question? Yes?
Would you refer to that as tripotassium nitrate? Or?
We use tri, tetra, and all that with molecular compounds, not ionic compounds. So if you look at different books and some websites, they may use different terminology, but I just use the standard terminology that I talked about in the class. Any other questions? Now here I listed all elements that they had 1 type of charge. If they have multiple types of charge or more, you can, and I don't need you to remember those, but based on the compound that they give you, you should be able to distinguish that. What I mean is that, let me just go here, or I guess I can just open another one of these. So if I say Fe2O3, I say name this compound. Remember, if you have metals in the previous slide that I just mentioned, that they have 1 type of charge, you don't write the charge with Roman numerals in parentheses because you don't need to. If I say potassium, you know it's in 1A, it has this charge of plus 1. But if I say iron, you ask yourself, was it among the ones that she said? No. So for that matter, you should specify the charge with Roman numerals in parentheses. And I told you, you don't need to remember charges of iron, right? But I asked you to remember charge of oxygen when it forms an ionic compound. So it would be O2 minus, right? You remember that oxygen is in group 6A. It needs 2 electrons to reach an octet. That's why we have O2 minus. So if So again, you have two ways to answer this question. You know that here we would switch the charges, right? So probably here I had 2 minus, probably here I had 3 plus. So you write iron, what should I write here in parentheses? The charge of iron, which is 3, right? And I write oxide. The other way, if you don't like this way, you say that you have 3 oxygen atoms, right? And each atom has the charge of 2 minus. So you have overall minus 6 or 6 minus negative charge. And then you have 2 iron atoms. So you want to have, in order to have a neutral compound, you want to have the charge of plus 6. So you divide plus 6 by 2, you get plus 3. So that is the charge of iron. So it would be iron 3 oxide. Is this clear? Good. Okay, let me do another example. If I ask you, and this is, the tricky one. So there is can anyone know what is the name of this metal? Mercury, but what is its charge? So you have 2 mercury atoms. This is a polyatomic cation, okay? And you have 2 mercury atoms. Overall, you have charge of 2 plus. So what would be the charge of each of them? 1, right? So this is mercury 1. And this is mercury 2. Okay? And again, by knowing the charge of oxygen, you can answer this question. So what is the charge of oxygen? 2 minus, that doesn't change, and we call that oxide, right? So if you have, basically this charge was here that I wrote that there, right? And then this charge was there. Basically, we switch them, right? Or as I said, you can say that you have 2 oxygen atoms, right? Each has charge of minus 2. So what is the overall negative charge? Two multiplied by minus 2, right? Does that make sense? And then you have 2 Hg atoms. And you want to have overall charge of plus 4, right? For that to be neutral. So plus 4 divided by 2 would be plus 2. So we call this mercury 2 oxide. Okay? But in the exam, you may see mercury 1 oxide. I asked you in your free time when you're studying for the exam, write mercury 1 oxide and see what the formula will be. Okay? So now I'm going to write, let me see how many questions I wrote for you. 4 questions I'm going to write here. And then you log into Canvas while I write them, so you answer them and get extra credits. Because as I said, I want to help you increase your grades. And if you miss this lecture, just feel free to email me so I provide you with makeup. Okay? And try to answer with me, so when I go to the next slide or minimize this one, you will be good. And you can use your class notes and everything you want. Oops. This software doesn't let me to select everything. That's ridiculous. Okay, I wait for you to answer these, so I go to the next slide, and then I'll come back to this, okay? And more questions you can answer, more extra credits you can get, so. Question? You can also take a picture of this, so I can go to the next slide. So I'll make sure that I have the other two questions. Okay. I have two more questions for you. Yes. So make sure, ask me, your SI class leader, your tutors, any question that you have, so hopefully we can end the semester with notes. If I write A, B, C, D at one line, I can save the space. So for the next class, make sure to go over the materials that I talked about, and I try to increase my speed so I can catch up with all the questions and all that. But again, in the next class, if you don't know what is the charge of calcium, I don't know, you cannot write ionic compounds. And we need those to write chemical formulas so you can write chemical reactions and all that. So make sure to study all the materials well. Yes?